Okay, we're starting in section 3.1 with a process for dividing polynomials known as synthetic division. This is very helpful because unlike long division, this one is a shortcut and it uses only the coefficients from each one of our terms. So here are the coefficients from the first polynomial in the numerator. And then we're dividing by x minus 5. So our divisor will always be in the form of x minus a. So since this is a minus, this is a minus, a is just equal to 5. If it were a plus, then it would be negative 5. So if you remember, your process for this is you add going down, and then you multiply the bottom number going up. So there's nothing under the 4 to add, so we're going to bring the 4 down. So the bottom number is 4, we multiply by 5. So if you put little times out here to remind you, this is what you multiply by. 5 times 4 is 20. And we add these together and get 7. 7 times 5 is 35. Add those together. 5 times 15 is 75. And we're going to add those together. So the last number you have at the end is your remainder. So all of this ends up with a remainder of 60. So we need to put the variables back in. So let's go back up here to the top. You can see we started with an x to the third. Your new expression is going to be one exponent less. So this is going to be 4x to the second power, or 4x squared, plus 7x plus 15. And the remainder we're going to write as a fraction, just like we started with. So it's 60 divided by the same amount we were dividing by in our original expression, x minus 5. So here's our result after we divide our polynomials. All right, our second problem is a little bit different because if you look carefully, you can see there's a missing term here. We don't have an x squared. So anytime something is missing, we need to put a 0 in place of it. We need to have a placeholder for every value of the exponent, starting from the highest down to the lowest. So our coefficients would be 3, 0, negative 6, and 10. And because this is x plus 3, that means a is equal to negative 3. So again, start by bringing down the first number. Always bring down the first number. And once you get a number at the bottom, you're going to multiply. Again, you can write a little time sign there to remind you that's what you multiply by. So negative 3 times 3 is negative 9. Add those together. Negative 3 times negative 9 is positive 27. Add those together. Negative 3 times 20 is negative 60. And we add those together. So put the x's back with our result. We have 3x squared minus 9x plus 20 minus our remainder over x plus 3. So this is minus because we got a negative when we added them together at the end. So if there's not a negative, then it would be plus. And again, there is your result. All right, let's take a look at the last one. It's written in a little bit different form. It's not written as a fraction. It's just written as a division problem. But the process is the same. And again, if you notice here, we're missing the x term. So we need to put a 0 in place there. So we have a 1 for x to the third minus 2, a 0, and a 3. And a would be 3 for this problem. Okay, so bring your 1 down. 3 times 1 is 3. Add that up, you get 1. 3 times 1 is 3 again. Add that up, we get 3. And 3 times 3 is 9. And we get 12. So we have x squared plus x plus 3 plus 12 over x minus 3. So those are your steps for long division. I'm sorry, those are your steps for synthetic division. And remember, we're going to be using this throughout the rest of the chapter for several other things. So make sure you understand the process and can do it correctly. And as always, copy the numbers carefully. And for any addition and multiplication, if you need to, use your calculator.